let's take a look at the law of sines and see where it comes from. So just as a heads up, law of sines help us to find missing angle and angle measures and side lengths when you have a non-right triangle. So if you have like a right triangle, then you can use like Pythagorean theorem or SOHCAHTOA, right, to find the missing parts. But what if you have a non-right triangle? That's where law of sines comes in, as well as the law of cosines, which will be from 10.6. So let me go ahead and just show you where the law of sine comes from first. So remember we were talking about area of the triangle. So let's say we have a triangle ABC, and if I set the three ways that we can find the area equal to each other. So one was like 1/2 BC sine of angle A. Another way we could have done that was 1/2 AC sine of angle B. Another way was 1/2 AB sine of angle C. Remember, this is when we were doing the whole SOHCAHTOA thing, the sine to represent it as a height. We could do it from the A's perspective or the B or the C's. So we can, since the area of the triangle stays the same, we could set the three areas equal to each other. Then what I do is I can multiply both sides by 2. So if I multiply or everything by 2, right, I'm balancing the equation, notice that these are going to cancel out. So I end up with BC sine of A, AC sine of B, and AB sine of angle C. Then I'm going to divide all three expressions by ABC. So I'm going to divide everything by ABC and cancel things that I can. And when I reduce everything and clean everything up, I end up with sine of angle A over A equals sine of angle B over B equals sine of angle C over C. So this is called the law of sines. And you'll want to use this version of the law of sines if you're finding the angle. So if you're looking for an angle measure, you'll want to use this. It just makes it easier. Okay. If you're solving for a side length of a triangle, then you can use the reciprocal version. So A over sine of angle A equals B over sine of angle B equals C over sine of angle C. Again, remember, lowercase letters represent side lengths and capital letters represent angle measures. Notice that the angle measures always have a sign in front of them. Let's take a look at the following. Notice that you have sine of angle A over A, so they're across from each other, and you have sine of like angle B over B. So they're across from each other. So we can use a law of sines when you're given a side angle pair. So you need to have at least one pair of angle side pair or side angle pair across from each other to be able to use the law of sines. If you don't, then that's when you're going to use the law of cosines, which we'll learn in the future. Okay, let's take a look at an example. Solve the triangle rounding to the nearest tenth, and you're given this information. So the giveaway that I know right away that I will be able to use the law of sines because I see that I have angle A and side A. So I have a pair of angle side across from each other and like another piece of information. So I know I can use the law of sines on this particular problem. A lot of students find it helpful to see a visual aid for it, so I went ahead and drew this out. Again, you can label ABC wherever you want as long as the angles and sides with the same letters are across from each other. So across from angle A is side length A, okay, and then across from angle B is side length B, and so forth. Okay, so notice I have this pair right here, right? I have that pair, and then this little piece of information. So 10 over B over B. So the way I can set up this equation is by putting whatever I'm looking for on the top. So since it's an angle measure, I'm going to put sine of angle B over side B, which is 10, is equal to sine of angle A, so sine of 114 degrees, over side length A, which is 15. Okay, again, it's sine of B over B equals sine of A over A. Again, notice that anytime you have an angle measure, it's going to have the sign in front of it. So I want to get B by itself. So the first thing I'm going to do is multiply by 10 on both sides. So I get sine of angle B is equal to 10 sine of 114 degrees all over 15. And to isolate angle B, I need to undo the sine operation. So to undo the sine function, I take the inverse sine. So I take the inverse sine of both sides. So that undoes or cancels out the signs. Therefore, angle B is equal to inverse sine of 10 sine of 114 degrees over 15. So you want to put this into your calculator all in one go. Make sure you're in degree mode. You do inverse sine, which is second sine. And then you type in inside the parentheses, right, 10 sine of 114, close parentheses, divided by 15. And rounding to the nearest tenth, you will get 37.5 degrees. So angle B right here is 37.5 degrees. Once you know two of the three angles, right, you're able to find the third angle, right, because all the angles of a triangle, the interior angles of a triangle, right, add up to 180 degrees. So that means angle C can be found right away because angle C is 180 degree minus the given angle A, and then the angle B that we just found, 37.5 degrees, and that'll give you 28.5 degrees. So we know that angle C is 28.5 degrees. If I add these three angles up, they add to be exactly 180 degrees. Okay, so now the only missing part is side length C, right? Side length C is the only thing that's missing. So if I look at this pair here, I'm going to have C that's missing. I have angle C. And then I can either use angle A and side length A and angle B and side length B, but I'm going to use the one that's given to us because that's more accurate, right? The angle that we found, angle B, that's a rounded answer, so that's not going to be as accurate. So anytime you're able, use the exact values that are given. So now that I'm looking for side length C here, I'm going to put what I'm looking for on top. So it's going to be C over sine of angle C, well, angle C is 20.5 degrees, over A over sine of angle A. Again, notice that here, instead of having sine of angle C in the top, I just have the letter C in the top. And I did that because that's what I'm looking for. Remember, there's two versions of law of sines that you can use. You want to use whatever you're looking for on the top. In this case, side length C was what I was looking for because I want to isolate that. So if I want to get C by itself, I'm going to multiply by sine of 28.5 degrees on both sides. Right, if I multiply by sine of 20.5 degrees on both sides, these cancel out. C, side length C, is equal to 15 sine of 20.5 degrees over sine of 114 degrees. Again, put all of this into your calculator, and that will give you about 7.8. Okay, so side length C is about 7.8. And let's take a look at the triangle that we've just found. Let's make sure that it makes sense. Across from the largest angle should be the longest side. That's true, right? 15 is the longest side. Across from the smallest angle, 20.5 degrees, should be the shortest side, and that is also true. All right, let's try another example. Here we're given triangle SRT, and we have to find all the missing parts, rounding to the nearest tenth. Something that stands out to me right away is that I'm already given two angle measures. And when I'm given two angle measures, I can find the third one. So I can find angle T by subtracting from 180 the two known angle measures. So angle T is 91 degrees. Okay, so we've already found one of the three pieces that we need to solve for. So now we need to solve for side length R and side length T, and we're going to do them one at a time. So you can pick whichever one. Let's say if I wanted to solve for side length R, I'm going to have this pair here, and I also have the S pair right across from each other. I wouldn't use this T one because I don't have both pieces of information. So if I use that, then R is the thing that I'm looking for. So I have R over sine of angle R is equal to side length S over sine of angle S. Okay, again, just a reminder, when you use law of sines, angle measures always have the sine in front of them, and then side lengths, right, they need to both be on top or both in bottom, and so forth. So here, if I want to isolate R, I'm going to multiply by sine of 49 degrees on both sides. Cancel these out, so R is equal to 20 sine of 49 degrees over sine of 40 degrees. Put this into your calculator all in one go, and you will get about 23.5 units. So side length R is about 23.5. Okay, now we just have to solve for side length T. So side length T right here, I have T over sine of angle T is equal to, again, I'm going to use the one that's given to us because that's the accurate one, not a rounded answer, S over sine of angle S, right? The ones that are across from each other here. And to solve for t by itself, I need to multiply by sine of 91 degrees on both sides. So these cancel out. I get t is equal to 20 sine of 91 degrees over sine of 40 degrees. And when you put that into your calculator, rounding to the nearest tenth, it's about 31.1. Okay, once you have your answers, like we've solved for all the missing parts, let's go ahead and take a look at the triangle and make sure it makes sense. All three angles, when added together, should equal exactly 180 degrees. Across from the largest angle should be the longest side. Across from the smallest angle should be the shortest side. So our triangle here looks reasonable. Okay, let's have you try a problem. Solve triangle XYZ rounding to the nearest tenth. Okay, so the first thing you'll need to find, the only thing you'll need to be able to find at first is finding angle Y, right? Because you have the pair thing happening here. So sine of angle Y equals 4. It's equal to 772 over 6 multiplied by 4. Remember, you're trying to get Y by itself. Multiply by 4, then take the inverse sine of both sides. Put it exactly like so in your calculator. Make sure all of this is inside the parentheses. And you get 39.3 degrees. Okay, once you've found a second angle, you can find the third angle by subtracting from 180 degrees. And then once you have that angle, you can set up another proportion here, right? Z over angle Z, which is 68.7 degrees, equals 6 over sine of 72 degrees, and solve for Z by multiplying by sine of 68.7 on both sides. And you get side Z is about 5.9. So about 5.9 here. And angle Z was about 68.7 degrees. And again, you should see that all three angles add up to be exactly 180 degrees. Largest angle has the longest side. Smallest angle has the shortest side across it.